If you're curious how the component form of the dot product is related to the geometric form, let's take a look at where that relationship comes from. So here we've got vectors u and v with some angle theta between them. And suppose then I find the difference between these vectors, so u minus v is this vector from v to u. So now we can use the magnitudes of these three vectors along with law of cosines from trig to come up with a relationship. So we can say that the magnitude of u squared plus magnitude of v squared minus 2 magnitude of u magnitude of v cosine theta. So this is law of cosines, right? We got a, b, and c here. A squared plus b squared minus 2ab cosine angle between is equal to its side opposite squared. So magnitude of u minus v squared. Okay, and so there is our law of cosines using our angles there. So now in order to go any further, we're going to need to break this thing down a bit. So we're going to have to imagine the vectors u and v having components. And so let's imagine that they have three components. Then the vector u would be u1, u2, u3. The vector v would be v1, v2, v3. And then u minus v would be u1 minus v1, u2 minus v2, and u3 minus v3. So now we need to think about the magnitudes of these vectors. And so the magnitude of u would be the square root of the sum of the squares squared. So the square will undo the square root for the magnitude, and we'll end up with u1 squared plus u2 squared plus u3 squared. Same thing here, we'll end up with v1 squared plus v2 squared plus v3 squared. Here I'm not going to do anything with this right now. Don't want to make this more complicated than I need it. Equals, and now the magnitude of this vector squared will be u1 minus v1 squared plus u2 minus v2 squared plus u3 minus v3 squared. Now, we need to simplify this further, so we're going to need to expand that out. Okay, so this is still the right-hand side of this. So expanding this out, we're going to get u1 squared minus 2u1 v1 plus v1 squared, right? So first down and last here. Here, u2 squared minus 2u2 v2 plus v2 squared. I'm running out of room, so plus u3 squared minus 2u3 v3 plus v3 squared. Whew, that's a lot of variables, right? And so we've got this equaling this expression here. Now notice we can do some canceling here. I can subtract a u1 squared from both sides, a u2 squared from both sides, a u3 squared, a v1 squared, a v2 squared, and a v3 squared. And after subtracting all of that, on the left, I'm left with negative 2 magnitude of u, magnitude of v, cosine theta. And on the right, I'm left with negative 2 u1 v1 minus 2 u2 v2 minus 2 u3 v3. Sorry for running all that together a little bit. Okay? So, now we can divide by negative 2, and we'll be left with magnitude of u, magnitude of v, cosine theta equals u1 v1 plus u2 v2 plus u3 v3. And you'll notice that on the left side we have the geometric form of the dot product. On the right side we have the component form of the dot product, showing that those two forms are in fact equal.